Today, I'd like to demonstrate how Zscaler's cloud browser can provide secure access to both private and SaaS applications, and how we can provide a secure browsing experience with traffic forwarding via the Zero Trust Exchange and last mile data protection controls, all via the browser that the user already has installed on their device. Perhaps an organization requires to be able to provide access for employees with BYOD devices in the situation that they may have lost their laptop or device and require emergency access, or perhaps there is a requirement to provide partner or third-party access to internet and SaaS. Imagine that I am an employee attempting to access SaaS applications from my own device, and I require access to Office 365 Outlook. I visit Office 365 Outlook from my unmanaged device, and I can see that I am unable to gain access. The identity provider can provide a link for the user to be directed towards the user portal. In this case, I have already authenticated towards the identity provider, but failed conditional access for this specific application. But I am able to access my organization's user portal. Here I have a list of applications, SaaS and private. Depending on my role, different links will appear in the portal. For example, another user logged in as Mark, due to policy, will only see 2 applications listed, whereas I see a lot more. I now visit and access Office 365 Outlook, which I previously attempted to access via my unmanaged device. If we open the developer console, we can see that no content from the original page was ever loaded into the user's local browser, indicating that no data is ever downloaded to the end user's device. Now I can view emails, and of course every link that I click on via the isolated browser is protected by Zscaler. For example, if there was an email that contained a phishing link and I clicked on that link, that transaction would be blocked. Additionally, isolation can allow file uploads depending upon the isolation profile controls. In this case, I attempt to upload a malicious file, and this is blocked in line. The same is true for data that is sent from the browser, including blocking the attempt of the user from uploading sensitive data via inline DLP. Transaction logs indicate the user, the threat prevented, as well as other items such as URL, and that the user performed this via the cloud browser. Next, I try to access a private application. You will notice that this application in the browser isolation URL bar does not exist in public DNS. Yet I am able to access this application via browser isolation. You will notice that the web server is also listening on a custom port. Hyperlinks to other internal applications with different URLs or even the same host on another port are supported. Access can be granted or denied depending upon policy. If I bring up the developer console again, you will see that none of the internal web pages content was downloaded to my browser, obfuscating or hiding code and content of the internal web application. Here I am downloading a Word document. As you can see, the file is not downloaded to my local machine. Instead, I have the ability to view the file within Cloud Browser Isolation. You can notice here that a watermark is present, and this can be configured to show a username, a timestamp, as well as a custom message. If I try to print or save as a PDF, you will see that this is also being blocked. As part of my workflow, I may need to edit documents that I have downloaded from private applications or other sources and then edit them. As you can see, I can upload these files to OneDrive and then edit and open within Word. If I attempt to copy text from a Word document to my local machine, the policy restricts the ability to copy from the isolated browser to the unmanaged device. Now I'm going to access another private application, and here I will access a file and download it in the same way I did from the first private application. Again, the file is never downloaded to my local machine. I can view the file and all the same controls such as copy and print are enforced. However, when I open OneDrive, we can see that the file that I downloaded is not within the protected storage, as there is a demarc between the isolation containers used to access both applications, and so data cannot be copied or uploaded between these two containers. I can open a secure browser where I can type the URL or create new tabs. I visit YouTube and search for a video. Note how responsive isolation is with these rich applications and the video content. As mentioned before, none of this content is rendered within my local browser, instead streamed from the cloud browser, and video playback and scrolling is the same as if I was to visit this website locally. This is possible because of our new turbo mode rendering technology. If I attempt to visit personal mail, this is blocked via policy from the isolated browser. Throughout this demonstration, you may have noticed that the isolated browser is shown with a padlock favicon prior to the name of the application, as well as a blue highlighted border surrounding the browser window. Notice that this is not visible when I visit Gmail within another browser tab. This is to differentiate between personal browsing and corporate applications. I also have a requirement occasionally to visit websites as part of my role, as if I am originating traffic from the US, whilst I'm based within the UK. Here we can see that my public IP address is shown to be located within the Washington DC area. Thank you for watching this short video demonstration where I showed how cloud browser isolation can provide access to internet, SaaS, and private applications for users and contractors browsing from unmanaged devices. Please reach out to your account team to learn more. We look forward to speaking with you.